are going to explain about classifying IoT devices in smart environments using network traffic characteristics. Introduction. The project covers the difficulties that smart environment operators experience in detecting and monitoring IoT devices linked to their network. It emphasizes the significance of IoT device visibility in assuring network security and preventing cyber attacks. The project presents a system for categorizing IoT devices based on network traffic and statistical parameters. Based on network behavior, the framework employs machine learning techniques to identify specific IoT devices. The study intends to assist smart environment operators in monitoring their IoT assets for presence, functionality, and cybersecurity without the use of specific devices or protocols. Objective. The project's goal is to create a system that can automatically classify Internet of Things devices in smart environments based on network traffic patterns. The system intends to evaluate data sent by various IoT devices, extract significant features using the bag of words technique, and develop a prediction model by employing machine learning techniques such as navy bias and random forest. The ultimate goal is for a single administrator to be able to efficiently monitor and manage an increasing number of IoT devices from various domains in a centralized server environment using historical and test data from the provided dataset. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload IoT Traffic Traces Dataset. This module involves obtaining the necessary dataset containing network traffic traces from IoT devices. The dataset contains network traffic data sent by various IoT devices including roadside cameras, body temperature monitoring devices, door close sensors, etc. Second module is Run BOG and navy bias to get device class. In this step, the bag of words technique is applied to convert the raw network traffic data into a matrix representation. The BOG matrix contains header representing words and rows representing the count of those words in each device's traffic data. After transforming the data into the BOG matrix, the navy bias algorithm is utilized to process the matrix and identify words that have high occurrences or counts. These high occurrence words are considered as valuable features for device classification. Third module is Generate, Training and Test Model. With the BOG matrix and the device classes determined by navy bias, the data is split into a training set and a test set. The training set is used to build a machine learning model that is random forest using historical data. This model learns to recognize patterns in the BOG matrix to classify devices accurately based on their network traffic characteristics. Fourth module is Run Random Forest Algorithm. The random forest algorithm is applied to the training data to generate a robust and accurate device classification model. Random forest is an ensemble learning method that builds multiple decision trees during training and combines their outputs to make predictions, reducing overfitting and improving classification performance. Fifth module is Classification Accuracy Graph. After training the random forest model, the classification accuracy is evaluated. The accuracy graph displays how well the model performs in classifying IoT devices based on the test data. The graph shows the relationship between the number of features used, the accuracy of the classification, and any potential trade-offs between the number of features and model performance. Sixth module is Upload New Test Data and Classify. To test the system's real-time performance, new test data is uploaded to the system. This data consists of network traffic from unseen IoT devices that were not part of the training set. The random forest model is then applied to classify these new devices based on their traffic characteristics. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. It contains test data and traffic traces. To implement this project, we have used this dataset. Importing this dataset contains the information of packet ID, flow duration, flow rate, IP prototype, etc. This is the main code file. This is run.bat file. Instead of executing a project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file. A graphical user interface will pop up. This is the graphical user interface. This graphical user interface is created by using Tkinter in Python. By using this GUI, we will interact with the project. Now click on Upload IoT Traffic Traces dataset and upload past devices data. And select Traffic Traces and open it. Here we can see that the Traffic Traces dataset is loaded. Now click on Run BOG and Navy BIOS to get device class. To get those domain names which are high in occurrences. So here in the above screen we got those devices data which are high in occurrence, and in last column we changed device name to ID, as random forest will not take string name and other values are domain name, count, etc. Now click on Generate Training and Test Model button to split dataset into train and test part. All machine learning algorithms will take 80% of the dataset for training purpose and 20% for testing purpose. 20% data will be applied on 80% trained model to know algorithm classification accuracy. If algorithm classify all 20% test data correctly, then its classification accuracy will be 100%. In the above screen, we can see the dataset size, and here we can see that the dataset is split into training size and split into test size. Now click on Run Random Forest Algorithm to train random forest. In the above screen in dialog box, we can see random forest able to correctly classify up to 98.41%, and in above screen we got device name for all 20% dataset. Now click on Classification Accuracy Graph to view random forest accuracy in the graph. In the above graph, x-axis represents test data and correctly classified data, and y-axis represents currently classification accuracy. From 100% test data, random forest is able to predict up to 98%. We'll close this graph. If we want, we can predict or classify for new test data also. Just click on Upload New Test Data and Classify, and select test data from here and open it. In the above screen, we can see first record data came from device TP link, and we got device name for other test data also. Click on Exit, and the final conclusion of the project is the experiment suggests that utilizing machine learning classification methods, notably Navy BIOS and random forest, together with network traffic characteristics, IoT devices in smart environments may be efficiently classified. The system can extract crucial information such as domain names and port numbers by evaluating data transmitted by these devices and translating it into a matrix using the bag of words technique. The random forest technique is trained on historical data to build a model that can accurately predict and classify new devices and test data. The successful implementation of the project using the provided dataset indicates the viability of automating device identification and monitoring, assisting administrators in efficiently managing an increasing number of IoT devices.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.